Good morning, AP Calc students. Ms.G here. Hope you're all doing well. First, a big thank you to my Coffee Tech and You students and all my students for helping me with technology. You are the best. I couldn't do this without you. All right, our lesson for today is section 5.6, Differential Equations, Separation of Variables. I hope you watched the Khan Academy yesterday on this topic. And I know that we have done some differential equations in class, so I'm just going to walk through a few to refresh your memory. All right, the first one is a differential equation. Whether they give it to you as y prime or dy dx, I'm writing it as dy dx, so that our first step, we can multiply both sides by dx, so that we end up with dy equals the quantity 4 minus x times dx. What do we want to do here? We want to get the x's on the side with the dx and the y's, if we have any, on the side with the dy. We don't have any y's here. We just have the dy. So we're all good right now. So what do we want to do? We want to integrate both sides. So we're going to integrate the left and integrate the right. When we integrate 1 dy, we get y. When we integrate 4 minus x dx, as you're all familiar with, I'm sure, we get 4x minus 1/2 x squared, and then we throw in a plus c for our family of curves, because this is our indefinite integral. Okay, and that's our general solution. Another example I have is example 4 on that same page, 366. dy dx is equal to 4 minus y. We multiply by dx so that we get the dx on the right, but we can't have the 4 minus y on the same side with the dx. So we group it and we divide both sides by 4 minus y. So we end up with 1 over 4 minus y dy equals dx. Then we're going to integrate both sides here. So if I integrate the left, I have to use a u/du substitution. So my u will be 4 minus y, and my du will be a negative dy. So on that side, I picked up a negative that's not in the original problem, so I multiply by the reciprocal of that coefficient, -1, which is -1, or I simply put a negative in front of the integral. And now I'm integrating 1 over u du, which you are experts at. And on the right, I'm integrating 1 dx. So now, the antiderivative of 1 over u, everybody knows, is the natural log of the absolute value of u. And we bring down our negative. We integrate 1 dx, and we get x plus our constant. Now what? Now, I multiplied by a negative to get rid of this negative here, because we want to isolate the L and u before we plug in our u value in terms of y's, and then exponentiate each side. So the u comes out, the 4 minus y goes in, and I multiplied by the negative. That gives me negative x, and it really gives me negative c as well, but that's just another constant. If this were c sub 1, it'd be a c sub 2, so we're just going to call it in general plus c. And then we have to isolate the y, which is embedded in a natural log function. So we're going to exponentiate each side, or if you prefer, you can put it in exponential notation. Either way, you will end up with 4 minus y equals e to the negative x plus c, this being the exponent. And what next? We're going to take e to the negative x plus c, and we're going to break it up into e to the negative x times e to the c. Now, e to the c is just a numerical value raised to another numerical value, which will give us another numerical value, and we'll just call that c. That's our capital C right there. And we like to put it in front of the exponential function. It looks better, and it's easier to deal with. So what do we get? Let's add y to this side and subtract the ce to the 4x from both sides. We will end up with y equals 4 minus ce to the negative x. Okay, hope you followed that. All right, let's try the next one. What do I have on this page? Example 8, page 366. All right, in this one, we have y prime equals x times 1 plus y. And I changed, or I rewrote the y prime as dy dx times equals x times 1 plus y. Multiply by dx. But now in this one, what's different is we have y's and x's. The y's can't be on the side with the dx. So we divide by 1 plus y. And then we have isolated the y's with the dy, and we have the x with the dx. So we're going to integrate the left and integrate the right. The antiderivative of 1 over 1 plus y is the natural log of the absolute value of 1 plus y. I could have done that with a u-du substitution. You could take that on the side. I didn't, but I know you know how to do that. And then I integrate x, which is 1/2 x squared, plus my constant c. I exponentiate both sides so that I can isolate the 1 plus y. And then what do I have on this side? E to the 1/2 x squared plus c. This is the entire the entire exponent right there. And then I break that up into e to the 1/2 x squared times e to the c, because remember when we multiply and bases are the same, we add the exponents, and that would give us this back. And now what? Constant raised to constant, or numerical value raised to constant, we get a capital C here, a numerical value. Putting it in front of our e to the 1/2 x squared, we get c e to the 1/2 x squared. What's happening on the left? We just kept bringing down our 1 plus y. And now we'll just subtract the 1, and we'll get y equals ce to the 1/2 x squared minus 1. Hooray, we got it. All right, so now the only other problem type I'm going to give you is write the differential equation for the following. In other words, for the following sentence, translate the words into a differential equation. And here's number 1. The rate of change of p. First of all, rate of change means we're looking at a derivative. And we're doing the derivative of p with respect to t. Hence, we get dp dt. Is our equal sign proportional. If it doesn't say directly or inversely, it just says proportional, we are assuming that it's directly proportional. So dp dt is equal to k, remember that from directly proportional, times what? Times, it's directly proportional to 10 minus t, times the quantity 10 minus t. There you have it. dp dt equals k times the quantity 10 minus t. I'll try another one. The rate of change of p. Here comes a derivative with respect to t. dp dt is equal to, that's our equal sign, is inversely proportional. That is k over what? K over the 10 minus t. So rate of change of p with respect to t, dp dt, is inversely proportional. K over something, k over what? Inversely proportional to 10 minus t, so k over 10 minus t. All right, I hope this is helpful enough so that you can get started on, the assignment. And here it is, ta-da, for March 17th. It's section 5.6, page 366, numbers 1 to 13 odd. Now, please check your answers in the back of the book and email me at, my email, if you have any questions. All right, and I hope you have a great day.